Hi, I'm Chuck Ingram. I work with a company called Slurry Pavers. We're a contractor that's been doing slurry surfacing work for just over 50 years. We're going to talk today about some slurry surfacing basics and of the slurry surfacing systems. We'll talk a little bit about some surface preparation and just how to get your roads into proper condition for these treatments. Before I get started though, I did want to make mention here, you can see that I also am a representative of the International Slurry Surfacing Association, the ISSA, acronym down here at the bottom. We have to give them a nod for allowing us to use their inspection manual as the source document for a lot of the training in the slurry surfacing modules. So I just wanted to give a shout out to the ISSA folks for allowing us to have access to a lot of good basic information. With this module, what we're going to start out with is talk a little bit about the history. Now, we're going to be going back into chapter 1 for these first several slides. The surface preparation part of it is where we're going to pick up in chapter 3. But the history and the background and everything has not been covered to this point. So what we wanted to do is just start out with a basic history of what is this slurry surfacing technique that we're going to talk about today. We'll talk a little bit about the history, where it all started. We will talk about each discipline and the differences between slurry seals and microsurfacing. We'll talk about the benefits of these treatments. There are different ways to texture this material based on volume of traffic and speed of the roadways that you're sealing. We'll talk about the aggregate options that we have in terms of how we can change the texture of the finished product. The right road, we're going to find out just what roads we're talking about that these treatments can be used on to gain full benefit of preventive maintenance. And once we decide which roads that we're going to be working on, we'll talk a little bit about surface preparation and how we go about getting these roads into the good enough condition that we're looking for. You know, we need to keep in mind that these slurry surfacing treatments are nothing more than preventive maintenance treatments. We got to start with a road that's in pretty good condition to start with. We'll use a generic umbrella, if you will, to describe the slurry surfacing applications as either a slurry seal or a microsurfacing. And during the course of these modules, you may hear those terms used interchangeably. And you might hear as well that the term slurry surfacing just to be used to be an all-encompassing definition. And this is about the point where I typically ask a class who has had any experience with either a slurry seal or microsurfacing, whether you've been on a contract as a contractor or an inspector. And so we're just going to briefly give a quick video of what this stuff really looks like as opposed to some of the thicker asphalt treatments that we're all familiar with. We'll start this job tour, if you will, at the stockpile. All the raw materials are stored here and being transported out to the job. Unlike your conventional hot mix paving operations, where your finished product is put together at a central plant and transported to a paving machine, with the slurry seal or microsurfacing applications, all of the raw materials are transported to the paving operation and mixed and placed on site. Here is something that was just being placed there, a fog seal or a tack coat that's going to be specific to this microsurfacing operation. And we'll get into that in a little bit later. But you can see that the materials here are being transferred from a support unit that we'll get into and describe here in a few minutes to a paving machine where everything is proportionately mixed and applied by the machine as it's going down the road. And you can see here the first difference between the plant mix operation and the slurry surfacing operations is the thickness. We're starting with roads that are in pretty good shape, and we're just going to apply something about 3/16 or 1/4 of an inch thick to an existing pavement that's in pretty good shape. Here we have the similar equipment, but we're placing a slurry seal that is typically used on lower volume roads, such as subdivision streets, maybe some low volume secondary roads. We'll get into the differences between this slurry seal operation and the microsurfacing operation in just a bit. But you can see that they're both mixed and applied to the pavement surfaces that they're chosen to be applied to. One thing that you might see later on in your exam is just where you use slurry seal or microsurfacing. And I'm sure I'll reference it here pretty soon, but the slurry seal here is going to be used on lower volume roads, whereas this microsurfacing is placed on roads that typically carry a little bit more traffic and a little bit higher speed traffic. And again, there's some really significant differences between these two treatments that we're going to get into as we move forward. A little bit about the history. Back in the 30s, as is the case with a lot of innovation, back in the 30s in Europe and Germany, they began experimenting with fine aggregates, asphalt emulsions, and some water, and mixing all these components together and placing them on a road to see what sort of a life extension that they could gain from applying this thin asphaltic mix to a road. Worldwide experimentation was ongoing, and then in the 60s, as we started to examine better materials and equipment and started to evolve some of that technology, things began to change pretty quickly. You know, we're still sticking with the same idea of mixing aggregate and emulsion and mixing it and laying it in a thin application, but now we've sort of gone to a point where we're adding chemistry to the emulsion, we're improving things, making things dry quicker. The first slurry seal in Virginia was placed by VDOT in about 1966. So this is a material that has been used, and the program has expanded significantly since then, obviously, but it's shown great benefit as a preventive maintenance, kind of a stopgap application to a road to extend the serviceable life. Then you move into the 70s and early 80s, as they really began to see the benefits of these treatments. We started experimenting with different additives and chemistry with the emulsions to improve the system. Again, back in Germany at this point, there was a company named Roschig that developed some very expensive thick pavement markings that was being used on the Autobahns. The pavement markings began to outlast the pavement themselves, and so they were challenged by the German Ministry of Transport to come up with a treatment that was thin in nature but durable enough to withhold the traffic and the speeds on the Autobahns, so they didn't have to replace these expensive pavement markings. So they came up with a mixture that they marketed as Rolumac. It was brought to the United States, and consequently the U.S. headquarters were set up in Richmond, Virginia. Slurry Pavers was asked to get involved in this development of a new technology for preventive maintenance on higher speed, higher volume roads. And in 1984, the first demo in Virginia was done for the city of Richmond. Shortly after that same year, Virginia DOT did its first job using the microsurfacing, which at that time, some of you may remember the term Rolumac. It was a specific trade name that was used for the product as it was developed. And it's now become a latex modified slurry seal, if you will, and just referred to as microsurfacing. You know, by the ASTM spec, slurry seal is a mixture of continuously graded fine aggregate, mineral fill or emulsified asphalt, and water, properly proportioned, mixed, and spread as a surface treatment, as we saw in that little quick video clip. When it's applied, the slurry should have a homogeneous appearance and fill cracks. Now, I want you to be real careful with that term. That's why it's kind of italicized and underlined there. These materials are thin, brittle asphalt overlays, essentially, and will not heal a reflective crack situation. However, if the cracks are wide enough, given the nature of the size of the aggregate that we're using and the viscous nature of the emulsion that's with that aggregate, we will be able to fill some of these cracks, if not bridge them, but certainly it's not going to go very far into being a long-term solution for reflective crack control. You'll see as we get moving ahead here that we will recommend that a separate crack treatment is used in combination with these slurry seals to help with the waterproofing of a pavement. But nonetheless, you still will be able to generally waterproof the surface itself and produce a high friction seal, as skid enhancement is one of the main benefits that we're going to realize from the use of a slurry surfacing mix. And again, just generally, a slurry seal is a blend of a crushed aggregate. For those of you familiar with the stone gradations in Virginia here, it's a number 10 rock dust and asphalt emulsion. It's mixed and spread in a mobile operation into a thin wearing surface, as we saw in the video. One thing you need to know and pay very close attention to, and keep in mind that this material will offer no structural value to the road. We're starting with a road that's basically structurally sound. What we're trying to do is buy some time into a pavement that's in pretty good shape. And typically, we're going to target a pavement that might be in that 5 to 7 year old range. That's just a general starting point. We obviously have to take time to investigate each individual site to be certain that we're dealing with the right type of pavement. But certainly, as we talk to people about to start off with a slurry surfacing program for the first time, we may encourage them to go back in their paving records and look at roads that are now 5 or 7 years old as a starting point. Again, we're staying with the slurry seal, and I mentioned before that it's generally used on lower volume roads such as residential streets and secondary roads. It's not going to be used to do any reprofiling of a pavement. It's not going to be able to fill ruts, and it can't be placed in multiple lifts. We'll get into the differences between that and the microsurfacing in a minute to describe that there are options to take care of those deficiencies in pavements. Now, the microsurfacing is similar in a lot of ways to a slurry seal with regard to where you're going to put the material down. You still have to start with a road that's in very good shape, or pretty good shape to start with. The main difference between the microsurfacing and the slurry seal is that with the microsurfacing, it's modified with a polymer or a liquid latex as it's milled into the emulsion. We're not using a polymer modified emulsion with the slurry seal. We're starting to get into a little bit higher grade seal coat material here with the microsurfacing. Due to the chemistry in this mix now, we're able to lay the microsurfacing in multiple lifts, where one of the characteristics of a slurry is that it was a one rock mono layer type of a sealer. With the microsurfacing, due to the fact that with the chemistry in the mix and it sets and cures a little bit quicker than the microsurfacing, we can level consolidation type ruts. You need to be very careful with rut selection and what criteria actually are required to be able to qualify as a rut that can be leveled and filled with the microsurfacing. And due to the chemistry, the microsurfacing will dry a bit quicker than your conventional slurry seals. The microsurfacing, again, the main difference that we talked about was the fact that it was modified with polymers or latex in the emulsion. So the question is, what benefits do you gain from modifying a liquid emulsion with a polymer? You're going to reduce the temperature susceptibility, number one. It may not have the tendency to flush in hotter weather. It doesn't have really ductility, if you will. There's not that much latex in the mix, but it will remain not quite as brittle in colder temperatures. So it's going to be a little bit more forgiving as we get the wide range of climates that we have in this part of the world. It'll remain stable in thicker lifts. We go back to the slide before where we said that slurry seal cannot be placed in multiple layers, but microsurfacing can. And due to the chemistry and the modification of this emulsion, we're able to put more than one layer of microsurfacing on top of each other. It's quicker setting. Again, the chemistry will allow for return to traffic to be accomplished in a much quicker time frame. By your Virginia spec, we're going to target about 60 minutes, 1 hour to be traffic ready versus the Slurry Seal, which is not modified. The emulsion is not modified. We may experience drying times of anywhere from 1 to 3 hours with a Slurry Seal. Due to the fact that you have modified it with the polymers, one thing we do know for sure is that it's going to retain the asphalt, or retain the aggregate in the mix a little bit longer, a little bit better, making for a more durable mix. So with the latex in the mix holding the rock together, we're going to hold skid numbers a little bit higher for a long period of time. Whereas the Slurry Seal was recommended to be used on lower volume roads, now we have this microsurfacing mix that's able to be used on a higher volume roadway. It was developed to be used on higher volume roadways. So we tend to see most of our microsurfacing work within Virginia DOT schedule work to be on higher volume roadways such as primaries and even interstate highways. You can identify and fill consolidation type rutting, which can be roughly translated as top layer rutting, composite pavements with asphalt overlays on top of a concrete roadway. The consolidation is going from the top down and typically not moving through the base or the sub-base of the materials. That's one type of consolidation rut that we're fairly comfortable being able to remedy with the microsurfacing. But you need to be careful where to use it, and rutting that's typically described at intersections or at bus stops is typically more plastic deformation than consolidation type rutting, and that's really not a good spot for this type of a fix that you can expect microsurfacing to work for you. It is quicker drying than slurry, again, due to the chemistry and the modification of the mix that we're using. And unique to the microsurfacing, it can be placed at night. We already discussed the fact that you can place it in multiple lifts for extra durability and extra life. You know, you notice the two stars there. What I wanted to clarify and just qualify on that one is that even though, yes, you can lay the microsurfacing in multiple lifts, you got to be careful cost-wise in that once you get beyond 2 layers of microsurfacing, you're probably into the cost range of a hot mix overlay without gaining any significant benefit from more layers of microsurfacing. So just be mindful of what the limits of this material are and what it's designed to do. Just quickly to bring you up to speed on some of the vocabulary that might be used here, when we talk about an emulsion or a mixture beginning to break, that is the point where that wet slurry seal or that wet microsurfacing on the road surface begins to change from a slurry state to a solid state. It will probably evidence itself more likely with a change in color. If you're to stand still and let the paving machine pass by you, within a time frame that it takes that machine to go a couple of 100 feet, you'll see that at application it's more of a milky brown type of a color. By the time the application equipment gets a couple of 100 feet away from you, on a nice day you'll be able to physically see the change in color, and that's when the change from the slurry state to a solid state is beginning. Some of that water is evaporating, the asphalt emulsion is taken over on the surface, and you'll have what used to be a milky brown color might take on pretty quickly a darker appearance. We'll talk about the set, and that's when it's just a little while longer, a little bit longer. With a slurry seal, it could actually take up to an hour, and in microsurfacing, within about the first 30 minutes, that matte that had changed colors a few minutes before is now going to be capable of certainly foot traffic across the mat. Now, if you were to happen to take your boot and walk across that mat within that 30 minutes for microsurfacing, or within an hour time with Slurry Seal, you may see some clear water being pushed out from the edge of your shoe. You know, that's when the material is beginning to break or rather to set. It's not quite ready for full-time traffic just yet, but it's well on its way, and that's an indicator that you probably have a mixture that's on track to doing just what it's supposed to do. The curing is when you're finally getting to the point where you are traffic ready. Again, by specification on the microsurfacing, it's going to be around an hour before you can call this material cured enough to accept full run in traffic. The Slurry Seal may take up to a couple of hours depending on ambient conditions. The Slurry Seal is a little bit more dependent on ambient conditions for that final cure. Traffic time, obviously, is when the material can be driven on and open to traffic without damaging the mat. As I said, Slurry Seal, it could take up to 2 or 3 hours depending on the sun, the absence of sun, a little bit of breeze, higher humidity, cooler temperatures, surface temperatures. There's a lot of factors that come into play with delaying the Slurry Seal from being traffic ready, whereas the microsurfacing and the chemistry in that material, we should expect to have full running traffic in an hour or less. Just a quick cap on that, the benefits and the capabilities and the limitations. Your Slurry Seal cannot fill ruts. It's not recommended to be placed more than 1 layer thick, so no double applications of slurries. And you cannot place the slurry typically thicker than 1 stone thick in one pass. One thing that was not really discussed was the residual asphalt content with a Slurry Seal is by design a little bit higher than with the microsurfacing, and thereby you don't want to be stacking stones, if you will, and putting more layers of Slurry Seal down because you've got a lot of raw asphalt in that application. With the microsurfacing, you have a little less residual asphalt content because you've taken some of the liquid asphalt out and replaced it with some liquid latex. So you do have some extra binder in there, but you don't have as much free asphalt in the mix. So for that reason, you are able to place a double application of microsurfacing where we don't recommend it with a slurry. You are able to place it a little bit deeper and fill some ruts with the microsurfacing. Benefits of all the slurry surfacing systems, if you will. You're going to hope to extend the serviceable pavement life. You're going to decrease the pavement permeability. We're placing a seal and a waterproofing seal across the width of the pavement. Depending on which gradation of stone that we'll get into in a few minutes, you're going to significantly increase the surface friction. We sometimes refer to those as hot spots when you have skidding problems in wet weather. And we'll put an asterisk by the bottom bullet there, correct moderate bleeding and flushing, and we'll discuss that in a later module. But there are possibilities of being able to correct some flushed pavements with one of these treatments. You're going to fill the surface voids and cracks. Again, be careful with that filling cracks versus sealing cracks. Minor depressions can most times be leveled, particularly with the microsurfacing. Don't expect your regular Slurry Seal to do any contour or changing of profile. We're definitely going to be able to retard the oxidation of an underlying pavement. That's what we're after, is to capture that road while it is still in a good condition. Maybe it is oxidized during that first 5, 6, 7 years of its life. We're going to put a new layer of life on top of it and create a new wearing surface. Properly trained crew and properly calibrated equipment, we're going to be able to apply a uniform and smooth appearance. Again, goes back to your choice of aggregates and what gradation and what surface texture you're really trying to gain. But we're going to be able to apply these materials to uniformly create a nice road. And they're thin enough, regardless of the gradation of stone used, that you're not going to be putting a full depth thickness of any type on these pavements. So you're not going to have buildup at curb interfaces or bridge scuppers. You're not going to affect the weight limits of bridge surfaces. You're not going to affect the overhead underpass height restrictions either. So we've got thin, durable treatments that we're talking about. So where do you put it? You know, what is the right road? You know, we touched on it. We've got to be looking for a structurally sound pavement. You know, I'd said 5 to 7 years earlier, but somewhere in that 4, 5, 7 year old pavement surface should certainly still be something that's got some structural integrity in it, that might have some spot failures that can be taken care of, such as some minor cracking. We'll just determine what type of cracking that is there, and we'll use the proper materials to seal those cracks, and again, not depend on the slurry seal or the microsurfacing to fill those voids or those cracks. Local failures are okay. You can see here, you know, there's some throw and go patching that was done in this little slide picture here, but if you've got some localized failures, certainly don't rule out a pavement that has a need for some minor pothole repairs or some utility cuts that need to be leveled, or even some deep repairs that need to be made on a random basis. These pavements can still be salvaged by slurry seal treatment in the proper preparation. A slide like this is something that everybody has seen at one point or another. It just kind of graphically goes into showing just the benefits of a properly timed and properly placed preventive maintenance application. I'm not going to spend a whole lot of time on this, but let's just start with this red line right here. And it's a theoretical life of a pavement, if you will. Okay, we're going to start off, the bottom bar is the age of the pavement in terms of years, and the left-hand axis there is the pavement condition. We're obviously starting off with a newer road that's in pretty good shape, excellent condition here, and the red line, as it goes over time, just loses some of its integrity. We will say a theoretical lifetime of 13 years or so here is when your standard hot mix asphalt pavement may be in some serious need of something other than a slurry seal come 13 years of age. So we will argue that in the first 75% of that life, or roughly 9 or 10 years, that pavement is starting to lose some of its structural integrity. In that first 75% of life, it's going to lose about 40% of the quality that was built into the road, which is a very opportune time to capture that type of deterioration with a thin treatment such as a slurry seal or a microsurfacing. If you were to wait yet another 12% or on up to that 13, 14 year life, you're going to lose another 40% pretty quickly. And that's going to put you beyond the time when the preventive maintenance idea really is sort of a bang for buck decision. If you capture the pavement condition up in here in the good to fair range, comparatively, you can extend the serviceable life of that pavement for about $2 versus waiting, coming down here to the bottom end of that curve, where it could cost you up to 8 or 10 times as much money to rehab or reconstruct a road that's been delayed. So delayed pavement maintenance is just going to translate into more dollars. When you look at your schedules in Virginia, for slurry seal or microsurfacing, we're going to see a reference of a type A, a type B, or a type C mix. All that refers to is the size of the aggregate that's being used in the mix. Technically, they all fall under the number 10 rock dust category, but inside that number 10 rock dust are sieves that will allow for different gradations to be used for different thicknesses of pavement treatments and different desired results. For instance, the type A mix is a very, very fine mix of the number 10 stone. Right now, it's Northern Virginia District within VDOT is the only district that's employing the use of a type A type of an aggregate in low volume curb and gutter residential streets. It was a conscious decision on behalf of the department to go with as fine and smooth a gradation of slurry seal as they could get, and there is some stone source available in Northern Virginia to achieve that surface texture that they were looking for in the residential areas and not give up the preventive maintenance way of thinking. The type B is just a general versatile gradation, sometimes used in double lifts when using a microsurfacing. It's a general gradation that's used for a lot of other slurry seal and secondary road slurry seal applications. It's sort of a middle of the road gradation. Not till we get into a type C mix where the rock in that particular gradation of number 10 aggregate is about the size of a fingernail. It'll be the largest size rock that you'll be using there. It'll give you the most aggressive gradation. The higher skid numbers will be achieved by using the type C aggregate. And if we have to get into any reprofiling or rut filling work with the microsurfacing, this is the gradation that we're looking for to be used there. And just a graphic example of, what do the type A, type B, type C gradations look like. And you can see from A, B, and C, they do gradually get a little bit more coarse, a little bit more aggressive in terms of surface texture. And you can just envision where some of these aggregates may be better suited. Again, the type A rock on the left-hand picture there is widely used in Northern Virginia and curb and gutter subdivisions just like that. Elsewhere in the state, residential and lower volume roads typically lean toward the type B slurry seal for their applications. And the type C stone or the rougher aggregate, the larger of the three options, would be used on your higher speed, higher volume roadways. All right, that's going to wrap us up for the tail end of Chapter 1 with the basics of slurry, the history of where these treatments came from. And you can check with your facilitator to review some of the knowledge checks, or if you have any questions about what was covered here in Chapter 1 as we wrap up just the very basics of slurry surfacing.